Hello, geometry kids. Today we're taking a look at section 1.4, measuring angles. What is an angle? Good question, Chris. An angle is the gap formed between two intersecting rays and everything like it. That's what the phrase at all means. Okay? So let's take a look at what I'm talking about. I have two rays here, as you can see, that are intersecting at this point. This gap right here, this gap right there, this is your angle. Okay? Now, every ray is made up of two sides, right? So this is a side right here. This is a side right here. And then the point where the two rays intersect. This point is called the vertex of the angle. Okay? Now let's talk about naming an angle. Remember that every time you have two rays, each ray has to have at least 2 points on it. As you can see, I've got ray BA in the picture intersecting with ray BC at the point B, the vertex. Now, to name an angle, there are two different ways. I can either use one letter or I can use three letters. Now, this option right here, even though it's longer, is actually the best way to name an angle. And I'll talk about why in a second. All right. Now, if I'm going to name an angle, then I have to at least use the vertex. The vertex of my angle is vertex point B. So I can name this angle B. Now this is how I draw my angle sign. I draw a little angle with an arc through it to show that's my angle, and then I put the letter B there. When you see this, you should think of some angle with a gap in it. Now, I can also use three letters. If I wanted to name this same angle B using three letters, I can do one of two orders, but whichever order you pick, you have to make sure that that vertex angle is the letter in the middle. If you think about it, if I trace my angle, if I wanted to draw this angle by hand, if I started at A, went to B, and went to C, then I would create that gap there, right? Or if I went from C to B to A, I would create the same gap, correct? But if I went from A to C to B, that would not be the same gap that I want. So, that being said, what are the two correct ways of naming this angle? I could name it angle ABC or angle CBA. Get it? Okay, so those are the two ways to name an angle. Now, one small more idea that we want to talk about. We know that we have points A and C on these rays, right? And I've drawn them in there. But moving forward, you should realize that if I don't want to draw that point in there, I can just put the letter A and the letter C on those rays, and we assume that there are points there. We don't actually have to draw little dots, okay? Now let's look at another circumstance that we're going to face often in this class. I now know, I see angle ABC in my picture, but what if I introduced an extra ray, a third ray, in the interior of this angle, say drawn right here, passing through point D, right? So let's put a D in here. Ooh, he's big. Let's move him over. Okay. Now how many angles do you see here? That's right, there are three angles, right? So, unlike before, when there was only one angle, if I said angle B, you know exactly which angle I'm talking about. But in this case, if I said, hey, Javi, where's angle B? Well, Javi would have three choices. He could say there's top angle B, there's bottom angle B, or there's this whole angle B. Agreed? Right? So there would be what we call in the business ambiguity when describing this angle with just one letter. So we can't use one letter. If you ever see more than one angle at the same vertex, right, like we have in this case, then we can't just use one letter. We have to use the three-letter option, okay? If I said, hey, Ada, where is angle ABD? Well, let's see here. Angle ABD. Well, let's see, that would outline this angle here. That would have to be that top angle, agreed? And we'd know exactly which angle we're talking about. If I said, hey, where's angle DBC? Well, that would be this bottom angle right here. Agreed? Nice job, Chris. Okay. And then lastly, if I said, where's angle ABC, the largest of the angles? Well, we would know that would be the entirety of the angle. Okay? So can everybody see why, if you see more than one angle at the same vertex, it's important to use the 3-letter method and not the 1-letter method? Now, again, if you only see one angle, then you can use the 1-letter, but it's never wrong to use the 3-letter option. Okay, now, again, an angle is a gap formed between two rays. So now let's take a look at how we measure an angle. All right? Would you agree that the two rays that I've got here, couldn't I widen or narrow these two rays? Does it make sense that the wider the gap between the two rays that I form, the bigger the angle measure I should use, right? Does that make sense? So this angle will be smaller than this angle, okay? All right, so how do I measure an angle? Well, the first thing is, it's important, the units we use in measuring an angle are degrees, okay? So we always measure units in degrees. Okay? And a degree measure would be applied to this angle. So I might say that this angle, say, 50 degrees. And we'll use that little symbol to mean degrees, right? Now, the notation we use when we want to talk about the size of an angle is, remember how when we talk about segments, if I say segment AB with a bar over it, that means think of the stick whose endpoints are AB. Whereas I say AB with no bar over it, that means tell me the length of that stick, say 5 inches or 12 feet or whatever, right? Well, similarly, if I want to measure an angle, I'm going to use a different notation than the angle, just the regular angle measure. Or I'm sorry, size. Sorry, the regular angle. So if I want to talk about the measure of an angle, instead of just saying angle ABC, I put a little m there. And that tells you whenever you see this little m there that you need to put a degree sign and a number there, like 50 degrees. So I say the measure of angle ABC is equal to 50 degrees, right? Now it's important that if you don't see this degree sign right there, if you don't see this little m, right, that says think of the angle itself, don't think of a number. This would be wrong. You want to think of just the gap, okay? Okay, the next thing we want to talk about is classifying angles by their measure. Now it's important to notice this phrase, classifying an angle, right? This classifying an angle is different from saying naming an angle, right? If you were to classify me, you might classify me as a teacher or gorgeous, but that's not my name. If I ask for my name is Mr. Kong, right? If I ask for the name of this angle, it would be angle ABC, right? When I ask you to classify an angle, then I want you to tell me what type of angle it is by how big it is. Okay, now the first type of angle that we're going to talk about by its size is a right angle. Here's my definition of a right angle. A right angle is an angle an angle is a right angle if and only if its measure is 90 degrees. Oh boy, look at that. There's our biconditional statement. I know that by this definition, if I see a right angle, I'm allowed to assume that it's a 90-degree measure. Also, I'm allowed to assume the converse. If I see an angle measuring 90 degrees, I could say, hey, look, there's a right angle, right? Now, how do I show that an angle is a right angle in a diagram? Well, typically, if I have angle ABC here, now this looks like a right angle because it makes a capital L shape, right? But if I wanted to actually show that it's exactly 90 degrees, I have to put a little square or box in that corner. That tells me that that's a right angle. Now, typically, what you'll see to make a right angle is, again, you'll see this capital L shape, or you might see like a lowercase t or capital T, right? All of these are ways of writing right angles, okay? So, but again, if you don't see this right angle box in the angle, don't assume it's a right angle. We never assume. Now the next type of angle that we're going to go back in size, it's called an acute angle. Now an acute angle is an angle whose measure is between 0 degrees and 90 degrees. Okay? Now I do want to point something out, just because we've been talking about language lately. Notice how I didn't write this definition in if and only if form. What that tells me is this definition will only be used to recognize the shape. We'll never use this formally in a what we call a proof or to find some missing value. Okay? Now, an acute angle is an angle who's between 0 and 90 degrees. Now if you think of that, instead of opening up all the way to make a capital L, if it's going to be less than 90 but more than 0, it would have to come back this way. All of these are examples of acute angles. You see that? Okay? So this is an acute angle. Okay? So draw this picture on your notes. Okie dokie. The next type of angle we want to talk about is an obtuse angle. An obtuse angle is an angle whose measure is between 90 and 180. So again, if you think about a 90-degree angle or a right angle, to make an obtuse angle, what I have to do is open it up wider than that capital L. Okay? But I don't want to go all the way flat. Okay? So this would be an example of an acute angle, like this. Okay? I could say this would be, for example, maybe 150 degrees, okay? And that's an example of an obtuse angle. Okay, and the last type of angle is an angle called a straight angle. It's called a straight angle because the shape of it forms a line, all right? So a straight angle has to look like this, where we flatten out and we just go straight like that, okay? This straight angle has to have a measure of 180 degrees all the way from here to here. No more, no less. And I don't know why I'm highlighting for no random reason. All right, since my smartboard doesn't want to cooperate anymore, I think I'll stop there for the day and we'll talk about the rest of this in class on Monday or Wednesday, depending on what day you have us.